In this video, we're going to talk about how to deal with fractions in equations. And before we get into the actual equations, let's review for a second what happens when we multiply a fraction here. So you see we have 2/5, and we're multiplying it by its denominator. So remember, we can multiply straight across. So this becomes 2 times 5, or 10. 5 times 1 is 5, and 10 divided by 5 is 2. Note that what we got when we multiplied this fraction by the denominator was the numerator. Again here, we're multiplying 7/3 times 3, which is the denominator. This time I'm going to simplify on the diagonal. Those are both divisible by 3. So 3 divided by 3 is 1. 3 divided by 3 is still 1. So now when we multiply straight across, we multiply 7 times 1 and 1 times 1, which just gives me 7. So again, we have the numerator. So hopefully you're starting to see the pattern. We can divide on the diagonal, making this 1 and 1. 8 times 1 gives me 8. 1 times 1 gives me 1, and we're left with 8. So you recognize that you can multiply a fraction by its denominator, and what you're left with is the numerator. So we can skip this part if we know that, because negative 2/3 times 3 will just be equal to the numerator. 4/5 times 5 will be equal to 4, and 9/10 times 10 is equal to 9. Now this concept will help when we start talking about fractions in equations. The other part that will help us is going to be, distribution. When we are solving equations with fractions, we're going to end up using distribution. So a quick review of distribution. This is just multiply. I'm multiplying 3 times the sum of a plus 5. So I do the rainbow. This gives me 3 times a plus 3 times 5, which is 3a plus 15. Now this is still distribution, even though the numbers that comes after the parentheses, sorry, we still do our rainbow from the multiplier. So in this case, we get 2 times 3 minus x times 3. So we get 6 minus 3x. So we're going to use both of those concepts when we deal with fractions in equations. So the first method is going to follow our regular method for solving one-step equations. We break the problem at the equal sign. We get our goal all set. We're going to look for x equals something. So in order to move this 3/5, we're going to do the opposite. The opposite is subtracting 3/5. And we do that to both sides. I don't know why I put it up there. Let's put it down here where we normally do it. So this is going to cancel. My positive 3/5 and negative 3/5 gives me 0, which leaves me with x equals 2/3 minus 3/5. Now remember, when we add and subtract fractions, we need to have a common denominator. So we're going to multiply each fraction by the other denominator. So we multiply 2/3 times 5/5, which gives me 10/15 minus, there we have 3 times 3, which is 9 over 15. We still have the x over here. So we're left with x is equal to, remember, if we have the same denominator, we keep the denominator and we subtract 10 minus 9, which gives me 1 over 15. Now remember, we're supposed to be checking these, so we put the parentheses for the variable. We're going to add it to 3/5, and our answer would have to be 2 over 3. So dumping in the number that we got for the x, 1 over 15. Now again, we need a common denominator. I know that 5 times 3 is 15, so I'm going to multiply that second fraction by 3 over 3. This gives me 1 over 15 plus 3 times 3 is 9, 5 times 3 is 15. Copy that 2/3, and again we get 1 plus 9 over 15. So 10 over 15 is going to be equal to 2/3. Now both 10 and 15 are divisible by 5, and this gives me 2/3 equals 2/3. So the check step is true. That tells me that for sure my x is equal to 1 over 15. Now, to me, this method is a little bit complicated. It brings in the fact that we have to add fractions, and I am well aware of the fact that most people don't like fractions. So let's see a way in method number 2 where we don't have to deal with the fractions. So my second example, x plus 1/4 equals 2. Remember that in our quick review, we remember that 1/4 times its denominator is going to be equal to the numerator. So because of that concept, I can multiply both sides of the equation by the denominator, and what it gets me is the numerator. So I have one fraction, its denominator is 4, so I'm going to multiply both sides of this equation by 4. Now you notice the second review item was distribution. So putting the side in parentheses helps me to remember that I have to multiply all of the pieces. So this gives me 4 times x, which is 4x, plus 4 times 1/4. We're multiplying by the denominator, so we get the numerator. And then 2 times 4 is 8. And notice here what we have is a two-step equation. So following our steps, we're going to identify what it is we're trying to do. That's getting the x by itself. So I need to move the 1 and I need to move the 4. I'm going to move the plus 1 first. I move a plus 1 by subtracting by 1. This leaves me 4x is equal to 7. And now we have a one-step equation. What's happening to the x is multiply by 4. The opposite of times 4 is divide by 4. And that leaves us with x is equal to 7 over 4. Don't forget to check. So we do our parentheses, plus 1/4 equals 2. I plug in my 7 over 4. Luckily, we have the same denominator, so we add the numerators. This gives me 8 over 4, and 8 divided by 4 is 2. So in my checking step, I get 2 is equal to 2, which is true. which tells me that my solution of x is equal to 7 over 4 is correct. Let's check out another example. Now we've got two fractions. Now we're still going to multiply by the denominator. Now you can find the least common multiple and multiply it once. I like doing it twice because the numbers are smaller. We don't have to worry about least common multiple. So multiplying both sides, I'll use the larger fraction first, the larger denominator first, sorry. So I'm going to multiply both sides by 5. So we distribute. This gives me 5 times x, which is 5x, minus 5 times 3/5. That makes the denominator go away, and I'm left with 5x minus 3. On the other side, remember, 5 is the same as 5 over 1. We multiply the numerators, which is 10, and we multiply the denominators, which is 3. So we had two fractions in the first part. Now we got rid of one of those. We still have a fraction, so let's multiply by the denominator again. Don't forget that you have to do it to all of the pieces. So both sides you multiply by 3. So 3 times 5x would give me 15x. 3 times 3 would be 9. On the other side, we're multiplying 10/3 by its denominator, which means we're left with the numerator. And now again, we have a two-step equation. So we add the 9 to both sides. This leaves me with 15x is equal to 19. We divide both sides by 15, and we're left with, sorry, I'm running out of room, x is equal to 19 over 15. Now we still have to check it, but I'm going to box it up so you can see it there. And in checking it, we use the original problem. So we replace the variable with parentheses, copy the rest of the problem, and plug in my 19 over 15. Now 15 is a multiple of both 5 and 3, so I'm going to make the denominators both 15 by multiplying this one by 3 over 3, this one by 5 over 5. So now they all have the same denominator. So we've got 19 over 15 minus 9 over 15 is equal to 10 over 15. So now 19 minus 9 over 15. And I know that 19 minus 9 is 10. Now there's no need to simplify this fraction. You don't have to divide by 5 because these are the same. So we don't care that they're simplified if it's just the checking step. So we see that that's true. And what we're left with is, for sure, x is equal to 19 over 15. I think we've got one more example there. So we can also use this method when the 2/3 is multiplying the x. So I see two fractions here again. I'm going to multiply both sides of the equation by the 3. Now this is going to get rid of the 2/3. So I distribute. So 3 times 2/3 will leave me with 2x minus 3 times 1 is 3. Oops. Have to multiply the other side by 3. Again, that's 3 over 1. So 1 times 3 gives me 3. 2 times 1 is 2. Now, Again, I've got a fraction, so I'm going to multiply by that denominator, distributing here. 2 times 2x gives me 4x minus 2 times 3, which is 6. Multiplying 3 over 2 by its denominator here cancels the denominators, which leaves me with just the numerator. And now we have a two-step equation. So I can add my 6 to both sides, leaving me with 4x is equal to 9. Sorry, I'm running out of room. Let's scoot over here. 4x is equal to 9. I'm going to move the 4. This is a 4 times x, so the opposite will be divide by 4. And I'm left with x is equal to 9 over 4. I'm not sure I have enough room to check, but we're going to try. So we get 2/3 x minus 1 equals 1/2. So plugging in my 9 over 4. I can see these are both divisible by 3. So this turns into a 1. This turns into a 3. I multiply across. 2 times 3 gives me 6. 1 times 4 gives me 4. Minus 1 equals 1/2. I am going to put in another page here and see if I can't grab us some more room. So we've got 6 over 4 minus 1 equals 1/2. Now, 1 with a denominator of 4, so I'm going to multiply this by 4 over 4. This gives me 6 over 4 minus 4 over 4 is equal to 1/2. And we get 6 minus 4 over 4 equals 1/2, or 2 over 4 equals 1/2. 2 over 4 can be simplified. They're both divisible by 2, and this gives me 1/2 equals 1/2. So that's true, which means my solution, which was over here somewhere, x equals 9 over 4 is my solution. Sorry, that one got a little spread out. So the best way to handle equations with fractions is to get rid of them. Remember that you can get rid of fractions by multiplying by the denominator.